So we're picking up where we left off last time. Chapter 11, Section 2. So, predicting floating and sinking. Yesterday we talked about the fact that water has a density of 1 gram per cubic centimeter. So water is 1. So knowing that water is 1, you can predict that an object will float or sink by knowing its density. So an object that has a density of less than 1 will float, whereas an object that has a density of more than 1 will sink. And we worked out the circle formula for the linear equation D equals m over v. Density is equal to mass divided by volume. That's definitely one of the things that you'll need to know for the upcoming tests that you're going to see. So density, remember, also will increase if mass increases or volume decreases. Likewise, density will decrease or get smaller if mass decreases or if volume increases. Buoyancy is something that is related to these ideas that water is 1 and density is mass divided by volume. The buoyant force acts in a direction that's opposite to gravity. I'd like you to write that down. Buoyancy or buoyant force acts in a direction opposite to gravity. So buoyancy force pushes up on an object that's floating in a liquid, whether that liquid is a pond, the ocean, or the sky, like a hot air balloon. Okay? And it makes the object have less weight but the same mass. So if the weight is less than the buoyancy force, the object floats. If the weight is greater than the buoyancy force, the object is going to sink. And if the weight is equal to the buoyancy force or the buoyancy, the object will hover in the middle of the water. Okay? The pressure on the bottom of a submerged object is greater than the pressure on the top if that object is floating or hovering. Actually, if it's hovering, they're equal. And the result is a net force in the upward direction. Okay? And that object will begin to float. Okay? And this is the basic principle that pretty much every ship, especially submarines, is based on. Okay? Even the cement ship that you see every year for the last 3 years when we go down to beach day twice a year. That ship was designed with what's called a ballast. Several ballast areas, which are areas of watertight air that is inside that multi-ton cement ship. And because the air buoyancy is greater than the force of gravity pulling down on that giant cement ship, the ship floated. Okay? It was because it was hollow and had that airspace where water couldn't get in, and because its buoyant force was greater than the force of gravity, that ship floated. Okay? Archimedes Principle. Okay, this is a big one. We're going to be doing a few labs on this, and it's pretty important. I'd like you to write this down. Archimedes' principle says that the buoyant force acting upwards on a submerged object is equal to the force of the weight of the volume of liquid the object displaces. Okay, I'll say that again. The buoyant force acting upwards on a submerged object is equal to the force of the weight of the volume of liquid that the object displaces. Okay? So when the film canister is empty, it floats. The volume of the displaced fluid is equal to the volume of the submerged portion of the can. This is what you're going to be doing today in your lab experiment. When an object sinks, the film canister sinks, the volume of the fluid is displaced by the can and is equal to the volume of the can. Okay? And this is the exact same thing you're going to be working on in laboratory today. Archimedes Principle. It's something that you have to think about multiple times. So you'll think about it tonight, we'll review it tomorrow, we'll do labs on it. But just remember that the buoyant force is equal to the weight of the volume of liquid that the object displaces. If it's floating with part of it above the surface and part below, it's just the percentage below the surface that you're going to consider, not the entire thing. You want to keep that in mind when you're working in lab today. Okay? All right. Before we get going on lab, I'll take a couple of questions to clear things up. Any questions?